So we'll go ahead and get started. Again, thanks for joining us today. We've got a great topic for you all, how to read and interpret the Waterfall Wi-Fi spectrum graphs. And we really seem to have struck a nerve, and we were talking about this a little bit before we started the show. This is a topic that Eric Camulli, our VP of Customer Success, came up with. And we had about 300 registrations within the first 2 hours of the email going out. So great topic, Eric, today. Really looking forward to hearing from you. We've, of course, got Jim Vada with us. As always, Jim is our Chief Wireless Officer, also CWNE 183. Welcome back, Mr. Vada.
Good to be here. Thanks, guys.
So a couple housekeeping notes, and then we're going to go ahead and get started. For those of you who are new to us, we do post all of our archived webinars on our YouTube channel. So if you search 7Signal in YouTube, please subscribe to our channel, and you can find all of the archived webinars there. These webinars are, of course, CWNP certified. So for those of you who are getting continuing education credits from CWNP, certainly let them know, show them the certificate that we can send you. Simply reply to any one of my emails and I'll get you to the right place for a certificate. I'm going to share two links, actually 3 links today. I've got the ROI report from IDC. You can have a custom ROI report. So actually seeing what the impact of digital experience is within your organization. We don't do any product tours or anything on these Wednesday webinars, so I will share a product tour link so you can register for those. Those are every Friday afternoon here at 7Signal. And then I've been talking about our podcast that's coming out soon, and I've got great news. We are now live on Podbean. So it'll start extending into Apple and Spotify and other carriers of podcasts here very, very soon. So you can search for the Digital Experience Podcast from 7Signal, and you'll find us there as well. So I'll start dropping in those links. So just a little bit about us. 7Signal started back in 2007, hit a lot of major milestones along the way. We're crunching a lot of numbers with our software and our analytics, serving up problems for our end users. We're crunching over 1 billion data points on a daily basis. That's a lot of networks, a lot of endpoints that we're on monitoring. We've got over 200 customers around the world, over 30 partners, a lot of whom are on today. I see lots of different countries logging in today. We've got 15 patents. We're GDPR compliant for those of you logging in from the EU. Not only do we stay relevant with our technology and our patents, but also we understand that privacy is paramount. So now why we're all here, I think it's sometimes lost on folks that aren't in the world of Wi-Fi or IT, just how powerful Wi-Fi is. And I was on the Wireless Broadband Alliance presentation yesterday, and they're really driving home the fact how more and more, over 5 billion devices are being added to the networks each year around the world, and how much that Wi-Fi is powering, whether that's the applications that your users are using in your offices or from home or somewhere in between when they're traveling. They're really they're powering your business more and more. And new buildings as they go up, the smart buildings, they're not being installed with wires. So there's no Cat5 cable being run in those environments. So whether that's keeping customers happy or satisfaction for those customers or patients in the hospital, more and more environments are becoming largely dependent on Wi-Fi. And what that means, if you don't have a monitoring solution, if you have no visibility into those environments, you're being reactive. So you're not being proactive and fixing issues before folks pick up the phone or send an email complaining about Wi-Fi. And if you don't have visibility, you're spending too much time trying to figure out what's happening on the network. You've got no visibility, and ultimately you're starting to point fingers. Is it the device? Is it the network? Is it the application? 7Signal tells you definitively what's going on. So there's less of a mean time to resolution, so you're getting right to the root cause of those issues. If you've got no visibility, you've got poor insights. You're not able to keep your workforce productive. You're not able to keep data feeding back into the electronic health record if you're in a hospital environment. You're not able to keep your students learning. A lot of universities and EDUs these days have students learning remotely. So you can't satisfy their needs. You've got SLA limitations. And you've got no plan to move forward. So that's where 7Signal comes in to make sure that you can keep your customers, whether they be internal customers or external customers, happy with the network. And what makes us different, before 7Signal, you're really getting an incomplete picture of your infrastructure. So your current solution providers, whether they be the access point manufacturers or you've got application performance monitoring solutions or other monitoring solutions, they're looking at your network from the inside out. And where 7Signal comes in, we are looking at the network from the outside in, where the end user experience matters the most, from the air, in the RF, and we're going to talk about a lot of that today, and also on those devices, so we understand what those experiences are from the end user's perspective. So this is a model that's going to be very familiar to you engineers on the line and some of you IT folks. This is the OSI model of networking. And where we get a lot of confusion is specifically around APM tools and where they stop and start. So this diagram will show you that APM tools look at 7, 6, 5, 4, 3, and they're not getting into the Wi-Fi layer. Where 7Signal, because we're on the outside of the network looking in based on those end user devices and the spectrum, we can see layers 1 and 2 where APM vendors stop. So there's been a lot of confusion around there, and specifically the importance of layer 1 and 2, which you're going to learn about today. So before we hand the controls over to Eric, I've got some trivia questions for you all with swag. So just as always, we are going to send some swag out to the folks who answer these questions correctly first. So I'm going to pull up the first one. And Eric, this is going to be your question that you served up.
Okay.
So I'm going to launch it, read it, and I'll give you guys a few seconds to respond. Let me know when you see it, Eric and Jim.
Yeah, looks good.
All right, so a waterfall spectrogram is 1-dimensional, 2-dimensional, 3-dimensional, or beautiful wall art. I mean, I think we can all agree that 4 is an obvious answer, but
I do have a
looking for something
chart on my wall here, actually, but
really,
that does not surprise me.
Whether it's beautiful or not, my wife, may not agree.
I've seen a few beauties in my day.
We'll see some today, I think.
All right, let's see how everybody did, Eric. Let's share the results.
Okay. Well, people said that it's a 2-dimensional chart, but to be quite frank, it is more a 3-dimensional chart. And the reason why is because the 3 dimensions are not only the channel or the frequency, and then the second one would be time, because we want to see when, but then also the third dimension is the magnitude or the volume of the frequency. So those are the 3 dimensions that we're going to be talking about and studying today.
Thank you, Eric. So we've got one more here. So if you didn't do well in that first one, maybe this will be more your speed.
That's all right. I went with 2-dimensional myself at first.
These are tricky, Jim, as you know. They get trickier and trickier each week. So
That's right.
Using the OSI model, in which layer would you find the spectrum? So I know that you all just saw that OSI model PowerPoint slide right before this one.
Mm-hmm.
So let's see how everybody did. They're still coming through. It looks like
testing.
Yeah, they're looking good on this. Let's see. Let's share the results. Mr. Vada, how did they do on this one?
Excellent. Layer 1, the physical layer, is where we will find the RF spectrum.
All right. So well done on the trivia side. Hopefully we'll get some swag out to you all this week. I'm going to hand the controls over to Eric Camulli, and we can start learning a little bit more about the spectrum. Mr. Camulli, the floor is now yours.
Outstanding. Thank you very much. Let's just make sure that we can get this going here. Okay, so hopefully you should be able to see that nicely. So thank you, appreciate that. Really happy and glad to be here. Eric Camulli, I'm head of customer success here at 7 Signal, and I work with our customers every day and all the time in order to help them get the most out of our system. And one of the coolest things that's inside the 7 Signal Sapphire Eye is a spectrogram, is a spectrum analyzer. Okay, so a lot of people, they don't realize, how powerful it is. They look at the charts that are generated and they say, gosh, I just don't understand what I'm looking at. I don't get it. And so we're going to demystify that today for you, so that when you look at a spectrogram, at a chart like this, at these waterfall charts, you are going to feel more comfortable, and that is the key. Okay. The other thing that's really exciting is that we are storing with our system 2 weeks of spectrum data in the cloud, which is pretty remarkable. As you know, trying to catch something that's going on in the air, it's like trying to catch a ghost. And so with that said, being able to see what's going on over time is really exciting. So here's our definition of the spectrum analyzer for you guys right here. We're talking about measuring the magnitude of an input signal, the magnitude. Now remember, we're talking about radio here, radio wave. So think of it as how loud the signal is. Is the signal soft? Is it quiet? Or is it loud? That's the magnitude. And we already talked about the frequency, okay? And obviously over time is how we're going to be measuring it. And what's really useful about the spectrum analyzer is that it's going to help us determine, okay, based upon the signature, based upon what we see, is this Wi-Fi or is this not Wi-Fi? The signature left behind by Wi-Fi is certainly different and unique compared to a non-Wi-Fi source. And when it comes to these sources of interference, guys, there's really only 2 things that you can do. You use the spectrum analyzer to identify it, okay? And even if you don't know exactly what it is, there's only 2 things that you can do. You can either eliminate it, and if you can't eliminate it, then you use the system to identify where it's coming from so you can avoid it. All right, so let's jump in right now. All right, so the first thing that we're going to do is we're going to talk about the parts of the graph. Here we go. So when we're looking at the spectrum analyzer, on the y-axis, as you can see, we have time. And this, you can see we're looking at a few days of data here from May 27th all the way down to the 3rd of June. On the x-axis, this is the frequency. Okay, we know them as the channels, channel 36, 40, 44. You can see the frequencies down there as well. And then the third dimension on our graph is the magnitude, is how loud, and we measure that in, as you know, the dBm. And this is the sweet spot right here. So we all talk about, well, what is a good signal strength? It's got to be right around this -65 area that I'm pointing to on the graph. And just pay close attention to the color. Okay, it's kind of this really nice aquamarine turquoise. Jim, would you say that's more of a turquoise?
Yeah, maybe a cyan, if you will.
Yeah, very interesting. Thank you for that. Okay, so and then obviously as the signal gets stronger, you're going to see, it kind of bleed into the yellow, orange, and red. So keep that in mind as we look through. And then, of course, here comes our chart. Water falling down. Okay, so water falling down from the beginning of the week to the end of the week. And as you can see here, okay, it's all divided up into our little 20 megahertz wide channels. And this is what we're going to dive into today. Now, when you look at this, again, it might be a little odd and it's your first time kind of taking a look at this stuff and you say, what is this big dark spot in the middle? Well, I'll tell you what, we're not allowed to use that big dark spot, all right? Those frequencies are not available to us. So our spectrum analyzer does not measure what's going on in that big black hole. So Jim, we're sharing the band here with some others, and so therefore, we shouldn't see anything in there, and obviously our spectrum analyzer is not measuring anything in there, right?
Yes, that's correct. That's licensed spectrum where Wi-Fi is prohibited from operating, so we don't even look because we shouldn't be there at all.
That's right, it's a secret. All right, let's continue. Let's just talk a little bit about this, okay? Just like how you tune in to your favorite radio station and you're listening to your classic rock FM, you're enjoying yourself, and then somebody else comes along with their radio, and then somebody comes along with their radio, and then before you know it, it's a big, jumbled, noisy mess, and you can't hear your favorite song anymore. And that's kind of frustrating. And you know what? This is what Wi-Fi kind of looks like sometimes. All of the, I mean, we can't hear them. I mean, not even bats can hear it. These are really super ultra high frequencies, but they're there, they're out there, and they are all meshed and colliding with one another, and it makes it really difficult for a transmitter to receive and for a receiver to get the transmission, and it can be very, very problematic. Okay, now sometimes the temptation is, okay, well, let's just shout over everybody. Let's increase the signal in order to overcome the noise. And that's where that SNR comes in so much. However, this is not a good practice. And the reason why this is not a good practice is because when we turn up the volume and essentially try to shout over everybody else in the room, we then become the nuisance. Okay, we are now the noisy neighbor. We're the problem. And so, and especially if you have access points or radios that are adjacent here that have the ability to detect what's going on around them, they may now even fluctuate their power and increase their transmit power to the point where now you're just right back where you started, and it's a big jumbled muddy mess where nobody can hear anybody anymore. Instead, the solution to this condition, it's really quite simple. Go someplace quiet. You gotta go someplace quiet. You use these systems in order to identify where is it noisy, and whether I know what the noise is coming from or not, whether I may be able to do something about it or not isn't the point. I want to avoid it. I need to go someplace quiet so that you can hear me and that I can hear you, and we can have a strong, robust transmission, communication. All right. So with that said, we are now going to dive into a few of these, and first we're going to take a look at the spectrum analyzer charts on the 2.4 gigahertz spectrum. All right, and we're going to start with a real simple one first, right here. So here we go, guys. Now, as you can see, once again, time is on the y-axis, and what I'm looking for here is I'm looking for the 3 columns representing channels 1, 6, and 11. Okay, so right here, this nice big wide column, this is a 20 megahertz wide channel right here. This is channel 1. In the middle, you can see, is channel 6. And over here is channel 11. Okay, and you know what I really like about this chart, Jim? It is nice and cool in between. Wow, look at that. It is nice and cool, nice and blue in between. So this is a great example of what normal looks like, wouldn't you say, Jim?
Yeah, I mean, this is about as good as it gets for 2.4 gigahertz. We don't have any black areas where there's, no energy in the band, but it's a noisy band. So having a chart like this is pretty good.
Yeah, well, I'm either happy or unhappy to report that it only gets worse from here. All right, so here we go. Here's our next one. All right, so now this is a little different. Now, the first thing that I want to point out for our audience here are these 3 spikes that happen all the way to the right. We got this spike right here, and then there's another one right here, and then there's a third one all the way to the left right here from top to bottom. Okay, this is your BLE, Bluetooth Low Energy, that is emitting from your access points. Okay, so if you have BLE turned on, think of this as like an advertising channel for Bluetooth. So just like when you pick up your phone and it says waiting to pair, it's like this constant advertising or beaconing that's taking place. Same thing in this situation. Nothing to be concerned about. It's normal. And the reason why there's usually nothing to worry about is because these little spikes right here, they don't interfere with 1, 6, or 11. So it's not a big deal at all. However, there are some moments when you can see that they got a little hot, they got a little red, and kind of indicating, whoa, there's some usage going on here. You see that right there where my mouse is? And at that time, you can actually see the line go across the chart, cutting through the spectrum, cutting through the band, indicating some kind of Bluetooth interference taking place at the same time. Now, when we talk about Bluetooth interference, these are these little 1 megahertz spikes. Bluetooth is a frequency hopper. And what that means is that it's part of the protocol where in order to try to avoid interference, it's going to go to this channel, this channel, this channel, this channel, hopping all over the place with these little 1 megahertz spikes, these little 1 megahertz spikes. And so you'll see it here, you'll see it there, and sometimes you'll see it everywhere, depending upon how strong it is. And Bluetooth, I mean, my goodness, Jim, I mean, we're seeing Bluetooth speakers and Bluetooth headsets and Bluetooth mice. And I mean, what else is Bluetooth? My goodness, it's everywhere.
It's everywhere. And anywhere you've got people with smartphones, they're going to have, BLE chips at least. Mm-hmm. But even if they're not connected to AirPods or watches or what have you, they're still, transmitting on those advertising channels.
Yep.
And out there looking for other devices. So it's almost everywhere we look now, we see the presence of BLE.
Yeah, and this isn't actually all that bad. I mean, it could be a lot worse. I mean, when I look down here where my mouse is pointing, you can see something that was pretty strong at this moment in time. You can see kind of like at this 8:34, 8:35 a.m., cutting across the band at this time doing, a transmission. And if you were using Wi-Fi at that time, there's the potential for collisions and disruption in your experience.
Yeah, and Bluetooth has a feature where it tries to just use the portion of the band that's not being utilized. So it tries to be polite, but Wi-Fi is so spectrum hungry. Like, look at all the spectrum that we're using. If we're using those 3 channels, we're using 60 megahertz of spectrum, and that doesn't leave much for Bluetooth. So it can only do so much to avoid interference and still get the job done.
That's right. I mean, they're going to wind up stomping on each other eventually, depending upon the environment. And that's what we're looking for. All right, let's take a look at this next one here. So this isn't quite so bad. So we're kind of taking a step back. Okay, so this is interesting because I wanted to show this example because it just kind of shows, okay, I like the spectrogram because it'll show me where the activity is. Okay, so here you can see a lot of activity on channel 6, very little activity on channel 11, and it looks like over here that you can see in the beginning of the day there was really little activity on channel 1, then all of a sudden we saw channel 1 pick up, and that's what this signature would look like. Okay. The other thing that I notice here that's really interesting is that you can see on channel 6 the transmission is not using the full 20 megahertz width. You see that? Whereas on the one before, it was kind of like from coast to coast. Here, you can see the signature is less than the full 20 megahertz wide spectrum. Now, Jim, I believe this is a good signifier of using lower, slower data rates, is it not?
That's exactly right. So when we're using 802.11b, we're using BPSK modulation, which actually has a different spectral mask. It looks a little bit different and only uses 20 megahertz versus or rather, it actually spreads out to 22 megahertz where OFDM uses 20, but it's kind of a gradual slope. And it looks a little bit narrower at the top. So I thought the same thing about this, Eric. It probably indicates an old access point that's only 802.11b capable.
Interesting, thank you. All right, let's move on. Okay, now we're starting to get into some nasty stuff, aren't we?
Oh yeah, pretty ugly.
So here's the nasty stuff. So once again, on 2.4, when you see these streaks going all the way from left to right across your screen, this wide band interference is going to be very disruptive to anybody who is on channel 1, 6, or 11 using Wi-Fi. And you can just see how strong it is by how red it is right here. So again, looking at time over on the y-axis at this time, to be able to see, wow, there was just a huge spike in this Bluetooth interference at this time. It's not uncommon. It's what we expect to see, which is why we work so hard with our customers on band steering and on making sure that if it's possible to turn off 2.4 radios in certain areas, that we go ahead and do that, because we just run into these types of problems all the time.
Yeah, unfortunately, the 2.4 gigahertz band more frequently looks like what we just saw than the first relatively clean graph.
That's right. That's right. Now, hey, Jim, what do you make of this one? This is really interesting. You've got this, you know, kind of like this top to bottom narrow band interference taking place. What do you think on that?
It's curious. So certainly there's the presence of those, you know, classic BLE advertising channels.
Mm-hmm.
One centered on 2425 and then the two on the ends of the band. And then, you know, if you look at the background, there's sort of in the lighter cyan, if you will, a bit of a washboard effect. That looks like Bluetooth, you know, the frequency hopping that the classic Bluetooth will do. But you also have those narrowband channels that are quite a bit louder, and they're being utilized much more frequently.
Yeah.
So I'm not exactly sure what that is. There's certainly Bluetooth going on.
Mm-hmm.
And, you know, we talked about how Bluetooth when it frequency hops, it does try to avoid the channels that are already in use, but I'm not sure if there isn't some other kind of unknown protocol operating here.
Yeah, that's right. And, you know, again, I'll say this, you know, whether we know what it is or not, doesn't matter. Okay, this is going to be disruptive to the Wi-Fi experience, and we need to avoid this. If we can't go to an area, and maybe we can identify what it is, it's like, it's coming from this over here, this security camera, for instance. We're not going to move the security camera. All right, it's there, it's in its place. And so what we do is we use the spectrum analyzer to identify where these things are coming from, and whether we know what they are or not, it's going to inform our decision as to whether or not we can actually use the spectrum in that area or not. Okay, and make some decisions accordingly. So this is pretty ugly. You can see that, you know, there's some semblance of channel 6 back here, but, you know, nothing going on channel 1, channel 11. I do not see the nice 3 columns that I would expect to see. All right, Jimmy, you ready for this next one?
Yes, sir. Oh, this one's my favorite.
Yes. Now, I think, did you have some personal experience with this one?
No, I hadn't seen it until you developed these slides.
Oh, okay. Well, from what I understand, this is an example at a hospital where we had all sorts of hearing aids that were in these chargers. Okay, so it's like a tray. And in the tray, all of these wireless hearing aids are now in the tray, and they're all charging in this base station all at the same time. And while they're doing that, they're all just kind of beaconing their Bluetooth over and over and over again, really hot to trot, really loud. And it's just constant. I mean, when you see this thing from top to bottom like this, I mean, it is just constant. It's not like it's transmission, it's transmitting data and then it's stopping for a while. I mean, this is just like this constant mode of transmitting. And you can see how, you know, it just kind of destroys the spectrum.
Yeah. Yeah, this is a, you know, really tough situation to deal with. One, because of the duty cycle involved. That's how frequently the interferer is transmitting.
Wow.
And this thing looks like, you know, 100% duty cycle. It's just always transmitting. And that means that a wireless protocol like Wi-Fi, which is very polite and won't use a channel that's being occupied, will just never get the access to the channel and never transmit. Every time a Wi-Fi client or AP checks channel 1 in this case, they'll say, "Oh, it's busy. I can't send any frames." And
can't get a word in edgewise.
Can't.
Right?
But it also, you know, helps with the identification, because you can see we're looking at, 2 or 3 days of spectrum data here, and this thing's just on all the time. It doesn't follow like business hours or some kind of business, process that you could sort of correlate with. Oh, this operation was happening at this time of day, so I know where to look at. This is, a system that's just operating all the time. So, it's some kind of automated full-time system, and that can, help.
With determining cause, yeah.
Exactly.
Yeah, and I want to invite our audience. I mean, if our audience is looking at these things and they have their own guesses and they have their own suggestions as to what's going on here, by all means, please put it in the chat. We'd love to hear from you. It's a lot of fun to look at these things together and make determinations. And again, we're just using all of our experience here at Seventh Signal in order to help out. And even if we don't know exactly what it is, again, doesn't necessarily matter, because it's just going to make what we're trying to do from a Wi-Fi perspective unusable. Therefore, we need to act differently and act accordingly. All right, let's move on to our next one on 2.4. And as you can see here, this is just a big, big mess. Again, rendering basically channel 1, channel 6, almost unusable. And this is just another great example of just a spectrum chart that looks just awful. Again, you've got to go back to your 3 columns, and that's your guide. That's your baseline, your 3 columns, 1, 6, and 11. And if you don't see anything that even comes close to resembling that, you're in big trouble.
Yeah, if your primary application in 2.4 gigahertz is Bluetooth, then you're looking pretty good. But if it's Wi-Fi, you've got some challenges.
That's right.
Comment from Ken. He says that one looks like a 1970s wallpaper.
I love it. Yep. Here's another example of these low data rates that we were talking about before. Very active on channel 1, channel 6, channel 11. It gets even thinner here. So you can see some transmissions that are wide, but a lot of them are thin. Moving on. Okay, here we go. We're coming down the home stretch of our 2.4 here, but oh my gosh, this is just horrible. Yeah, this is pretty nasty. This is likely our Bluetooth interference. As you can see, our BLE advertising channels are lit up pretty hot. And again, if you're on channel 1, 6, or 11 in this case, pretty good chance that your experience on Wi-Fi is going to be terrible. Okay. All right, and then finally, this is interesting because you can see where channel 6 and channel 11 are, being used lightly, but that there's this interference that kind of comes on in the middle of the day, okay? And then as you can see by the time frame on the y-axis that it kind of goes away in the middle of the night. You see that, Jim? So
yeah, that's a really important clue.
Yeah, it's a really important clue. So, use all 3 axes in order to figure out what in fact is going on. The color is going to denote just the magnitude, obviously the time, the middle of the night, and then you can see the channels on the x-axis. All right, so now let's switch over to 5 gigahertz and take a look at those examples. So Jim, this looks pretty normal to me. How about you?
Looks great. Lots of black. We don't see anything. We don't see high utilization of any channel, and we just kind of see the faint impression from the OFDM signals that Wi-Fi makes in the 5 gigahertz band. So this just shows a ton of available capacity.
It really does. I mean, nothing is really what I call hot to trot, really overutilized, if you will. Looks really great. So, I mean, starting here on the x-axis, channel 36, channel 40, channel 44, so on and so forth. This is a 20 megahertz wide channel plan. You can see it very clearly from all the way from left to right. Now this one, to your point, I really like because it does show, okay, what are the channels that are being heavily utilized? Like this guy right here, what is that, channel 100, I think?
Yep, that's 100.
Okay, really, again, a 20 megahertz wide channel plan. Okay, you can see that there. Okay, I don't see anything that would indicate, necessarily a 40 megahertz wide channel plan, although we'll see some examples of that in a moment. And each one of these little lines that you see, this little dash right here where my mouse is, I mean, that's just an indication of somebody using that channel, a transmission taking place, you know, uploading or downloading of a file at that time. Okay, and so, you know, again, it's, you know, start at the beginning of the day and to the end of the day, the beginning of the week to the end of the week, we're waterfalling down. And what's left behind is like the spectral trail. It's kind of like a Wi-Fi slug leaving its spectral trail behind, and we can see the activity that took place.
Hopefully
All right,
your
now,
Wi-Fi is faster than a slug.
yeah, hopefully, yeah. Now, Jim, this one is very interesting. What does this indicate to you here when you see something like this?
Well, yeah. So what I see is the presence of a AP operating in 80 megahertz wide mode, and its primary channel looks to be 108.
Okay, so here, 100, 104, 108. The primary channel is always going to be lit up a little bit more bright. That primary channel is the one that's being used for all of that management traffic, right, Jim?
Yeah, that's where all the beacon frames and authentication and association and acknowledgement, all those management frames are only transmitted on that primary 20 megahertz channel. So it always has a lot more utilization than the secondary channels.
There you go. And so, yeah, so this is what, you know, if somebody was connected at a high data rate and they were using, you know, they're using the full width of that 80 megahertz wide channel, it's going to light up just like this right here. Okay. When the full width of the 80 megahertz wide channel is not being used, the client is at a lower data rate, then that's when you're going to see what's going on below it here. Just instances where it wasn't completely necessary, right, Jim?
Yep, or maybe it's a client that doesn't support that channel width, or just, you know, authenticating, associating, and not really doing much.
There you go. Yeah. Now this one is really interesting. So when I look at this, I find this to be very interesting. Again, we're looking at a few days of data here, but look at this. Jim, it's almost as if this channel was in use and then it kind of stops and it picks up over here like there was a channel change. This is what a lot of channel changes would look like, don't you think?
Yeah, at first it looks like, oh, nice and clean, lightly utilized. You know, we don't see any channels that are just, you know, getting stomped on. Nice 20 megahertz channel plan. But then you're right, you look closer and you see the trails kind of ending and picking up on other channels. So that indicates a lot of APs changing channels quite frequently, which can be somewhat disruptive.
That's right. I mean, every time, you know, an AP changes its channel, you know, in the middle of the day, and if there are clients connected to it, they're going to temporarily get disconnected. So we try to, our recommendation is typically if you're going to do channel changes, do it in the middle of the night, you know, once a day. You know, you don't want to be doing these things every 15 minutes. Check your default settings on in your controller. Okay, look at this one, Jim. This is really interesting. Okay, now I find this very interesting because if you look all the way to the left, okay, you'll see this activity taking place at this time. It stops because we're not measuring in the middle here in this part of the band, but then it picks up again on the other side. It's as if there is something blasting completely across the 5 gigahertz spectrum, all the way from the left, all the way to the right. Have you ever seen anything like that before?
Not that covers all of Uni 1 and Uni 2 and some of Uni 3. That's uncommon.
Yeah, this is really uncommon. It actually is very concerning. It's rare. It's concerning, like somebody is like some kind of a jammer even that would just be blasting the entire spectrum during this time. And it's very concerning. You can see Wi-Fi energy over here on these Uni 3 channels. But it's interesting because, Jim, what I'm wondering is maybe the reason why it's so hot over here is because there's co-channel interference. Everybody's trying to avoid what's happening over here and the other channels, and everybody's kind of moving on over to a channel that maybe they think they can operate on.
Yeah, unfortunately, that's one of the consequences you'll sometimes see with auto channel planning. If you have sources of interference across the band, every AP may end up on the same channel that, looks like it's clean.
Yep.
And so you got to kind of figure that out and try to find more spectrum to use, try to take care of some of these sources of interference.
Yep, absolutely. All right, the next one. So check this out. This looks like somebody set up a 160 megahertz wide channel, wouldn't you say?
I think so, with a primary channel of, is that 48, I believe. Yeah.
Yeah, in the middle here, right. This guy.
Yeah. This is actually a great way to illustrate the inefficiency of using a wide channel like that. You
Yeah,
can see that there's all that traffic on channel 48 that we talked about, the management and control traffic. And it's only when a client that's capable of using 160 megahertz channel width has data to transmit, is actually transmitting data frames, that whole channel width gets utilized.
yeah.
So,
and by the looks of it, it looks like it's happening just a couple times a day.
yeah, really it does. In the meantime, that would be causing, co-channel interference with other APs operating on those same channels.
Yep, absolutely. All right, we're coming down the home stretch here, just a couple more that we want to look at together. This is very interesting. You see how the Uni 3 channels are completely trashed. I mean, this is not a good look at all, everybody. This is bad news. Now, I know, again, from experience, this is an example of some audio-visual equipment. Sometimes these AV systems, they kind of set up their own little 5 gigahertz network in order to communicate with the microphones and the speakers and the receivers and all of that. And unfortunately, it completely trashes the channels that it decides to use to the point where you can't use them for Wi-Fi anymore. So this is bad news.
Very, very disheartening to see this in the 5 gigahertz band, which is usually, if that's where we go when we see 2.4 gigahertz is a mess. Go to 5 gigahertz, it'll be nice and clean. And yet, for this unfortunate customer, the Uni 3 channels were just being dominated by that AV system day and night. Even when nobody was there doing karaoke, they were still transmitting away.
Yes, they were. And then our final slide right here, this is a really interesting one. You see this little wiggle worm right here, Jim, this little sliver here,
Yep.
top to bottom. Now, we were able to work with the customer in order to trace this down. This is very abnormal, so it looks very different than everything that we've seen so far, This is a motion sensor. And this motion sensor, again, just continually broadcasting, transmitting as it tries to detect motion, but basically renders this channel useless for Wi-Fi. Okay.
Yeah, it does. It looks pretty small, looks pretty harmless. Just that tiny little wiggle worm there on 153, but 100% duty cycle, loud enough that any Wi-Fi station on that channel will hear it and never transmit. So
that's right. Never use it. Exactly. Yep. So, and there you have it. Those are the examples that we had today. I hope everybody enjoyed that. Don, maybe there's time for a question or two. I'll leave that up to you. And Jim, I want to thank you for helping out here. This is a lot of fun, and obviously my sincere hope is that everybody listening today is able to learn how to use these charts and interpret them in a way that they couldn't before. Don, back to you.
Yeah, thanks, Eric. So I did see some questions coming through. Jim, did you pick up any that you saw?
I did. I saw a couple of good questions, couple of good comments. Question here from Tim. He says about the, I believe those were hearing aids. He says if the hearing aids were a real problem, would a Faraday cage around the charger station help?
Why wouldn't it, Jim?
Yeah, I mean, I suppose that's one approach to take. Build a metal cage around it that, you put all the hearing aids on there, put the cage on top, and
in a lockbox.
Hopefully that'll contain some of that RF. You might have better luck than complaining to the hearing aid vendor with that approach.
Agree.
All right, Mike, very good question here. He says, do overlapping wideband or CCI issues have a recognizable pattern in spectrum analysis, or is there no way to tell? So yeah, Mike, like we saw when we were looking at that 160 megahertz wide channel, it's very clear where the primary channel is because it's got greater utilization. So you can see when you have overlapping wide channels because you'll see two primary channels in use in the same, perhaps 80 megahertz or 40 megahertz or 160 megahertz. Hopefully you don't see that. And then you know that you've got that primary, secondary OBSS condition, which is really, really bad for contention. So spectrum analysis is a good way to discover some of those things. Maybe one last question here from Thorsten. He says, what's worse, co-channel interference or adjacent channel interference?
Both are bad.
They're both bad. We could probably do a whole webinar on this, so
Yeah.
I'll try to keep it brief, but most of the time ACI is worse, and that's because it causes an RF collision, and the frames that were being transmitted have to be retransmitted. In co-channel interference, often we're just sharing the channel politely the way the spectrum was designed to do. So one transmitter will back off while the other one's transmitting, and then it'll transmit when the channel's free. Ideally, that's what will happen. And so we can still, let contention work normally. We just have too many users on the channel than are necessary. So
yeah, totally agree with you on that one, Jim. I mean, if you're on the same channel, you can hear each other. If you're on different channels, it's like you can't hear each other, so you're just colliding over and over.
All
right, Don, I think that about wraps it up for the Q&A.
That sounds good, and we're right about on time here. Thanks, Jim. Thanks, Eric. Excellent presentation today. Looking forward to seeing you all next week. Keith Parsons will be joining us, and it'll be an Ask Keith session. So lots of open-ended topics for you all to ask your questions that you wish you had an opportunity to ask Keith Parsons. We're really looking forward to that one. So we'll see you all next week, 11 a.m. Eastern Time. Have a great week, everyone, and a great weekend, and we'll see you all then. Thanks again.